ordinary least square method. Is it clear? And now I just so this is an exact algorithm. This is a now parametric algorithm, and this is a machine learning algorithm. Yesterday what we did, this is not exact machine learning algorithm. Okay. So now this is a so before starting any algorithm, there is some assumption. Always. There is always some assumption we need to find. Oh, let speed of light is this. Let r is this. Let value of sigma is this. Always there is any assumption. So for implementing any algorithm, first what we need to know, what are assumption. Okay, what is the constraint of this algorithms, and then apply this. So what are the constraint? First constraint is this. Then I apply. And to sort of complete pure maths from scratch. Okay, you can write by own algorithm without any. Then I just show the function. Okay. So what is the first constraint? There should be relation between input and output. There must be relation. Then only we can search now. We are going to be search the relation between input and output. If there is no relation exists, how we can search? So first is there must be correlation between input and output. First constraint. Let us take another value. There is two value. X in is 2, x in is 2. Suppose that this is called the multivariate. Means this is called the multivariate. X input 1, x input 2. Is it clear? If you have a more than one feature, this is called multivariate linear regression. So what is the problem? There must be relation between dependent variable and independent variable, but there must not be any relation between feature. Understand what I am saying? Feature having no relation, but feature having relation with the labeled target. So if feature having relation itself, means one feature x1 having a correlation between x input 1 is relation with input 2, this is called the autocorrelation, and this is called multicollinearity. What is the meaning of multicollinearity? If feature itself correlated, that is a problem now. If I change x in and I stop x in 2, I am not changing input 2, okay, and if I only change x in 1, I got the same relation. Again I restrict x input 1 and I change input 2, again find the same relation. Is it good? Is it good? I find the same type of relation with input and out, with both type of input. My output respond same with input 1 with input 2. It is good? No. So we need to remove this feature. Is it clear? This is called feature reduction. Understand? Otherwise my size is increased, my computation is increased. So there is a lot of feature reduction technology are there, algorithm are there. PC, have you? Principal component analysis is one of them. Principal component analysis, what is the summary? It is going to be what I try to give a complete machine learning flow and how we can select or not. So we need to select the PCA, principal component analysis. Principal component analysis find the top uncorrelated features by selecting the eigenvalue, eigenvector and all. Is it clear? You might hear about what is eigenvalue and eigenvector. Okay. Again, there is another. If you work with the text processing, so SVM is not good. PCA is not good for feature reduction. There is another technique that is called SVD. Have you heard about it? Singular vector decomposition. Yes or no? So we are going to be use this thing for a lot of things. So I show one thing. So these are the then. Okay. So here I just considering one thing. What is the first restriction? First assumption? There is a relation between input and output. There is no relation between input itself. And second one is this called the multicollinearity. This third is the error. Whatever the error, whatever the deviation you got, it should be uniform. Means noise should be uniform noise. I'm going to show all these three. Means if I give the any inputs, the noise should be uniformly distributed. Is it clear? It is not like that if I change this bias, so this is called exactly biasing. Means biasing should be uniform. Is it clear? It is not if you for this input my biasing is 10, for this input my biasing is 12. Biasing uniform. I just show all things completely maths. Let us do. So what is the basic thing? What we need to do? What we do? We solve the linear equation without implementing math already in our childhood. Is it clear? The same thing. So what was my inputs? That is the 1, 2, 3, 4 and 5. These are my input values. I just showed the basic names style, but that is very helpful. So what is the exact value of 1? What is the exact value of 2? 3. What is the exact value of 3? 2. What is the exact value of 3? 4. And what is the exact value of 3? The data is completely non-linear, as I said. And this type of plot is known as a scatter plot. So whenever you have a continuous data, we have to go with which type of plot? A scatter plot, generally. If you have a continuous, if you have a categorical data, go with bar chart or like histogram chart. Okay. So now first of all, there is one outlier here. If I remove this outlier, maybe my equation becomes linear. Which one is outlier? This value. Will very deviating from my data. Okay, so what we are going to be do, this is the real value. This is called 1, 2, 3, 4 and 5. This is a real value and this is a actual input, real input. Any problem? So generally what we do, I try to, let us take this equation 1 and let us take this line 2 and let us take this line 3 and I call it, the line is YP1. I think it's clear. Predicted line 1, predicted line 2, predicted line 3. Let us take this equation. So I ask you, if I give you option to select the best line, tell me which you are going to select, P1, P2 or P3? How? How we can select the P2? Yes. So what we are going to be find, we are going to be take the distance from all the samples. Is it clear? Taking the distance from all the sample and check which line give minimum error. But this is problematic because drawing a line with the points are endless. Is it clear? We have a okay. So what is the goal to selecting the best fit line? What is the best fit line? Which give least average error. Is it clear? Now again question. Consider this line. Consider this line. This is a one error. This is no error. This is no error. This is error. This is error. Yes or no? And this is error. Yes or no? Okay. We are if suppose if I consider this line, this is if this consider second one line. This give the error, positive error. This give the positive error, and this give it's sub zero. That's why we need to take either absolute value, either square. Understand? Understand why I am going to be taking square? Because if suppose there is a -5 here and +5 here, when you average it, exact error become 0, but it having use error. Is it clear or not? So for this thing, what we are going to be called? So what is the goal? To find the line equation. To find the line equation. And finding the line equation, we need to know that this is called the predicted line equation, that we need to find the slope and we need to find the from where we need to start the line. Is it clear? So now we are going to find the slope and starting line. Okay, for all the point and calculating the error. What is the goal again? So this is called, let us take, I have an actual value. Please understand. This is actual value, we know the actual value. And what is goal? When you do the prediction value, it should be what? 0. It should be least. Yes or no? Again, but we are not able to, it is going to be done by all the sample, average. So I am going to be take its average, is it clear? And square. Is it clear now? So this is basically its cost function. Okay, and again I extend this 1 upon n summation of actual value minus mx plus c. Any problem?